welcome everyone. Yeah, so we're going to be doing a quick introduction to Niagara. Obviously, it's a really big, complex, powerful new thing, so we're only really going to sort of scratch the surface tonight, but hopefully it will be interesting and informative and give you a bit of a base to sort of build on with sort of further learning and things. Do ask questions as we go along. We'll probably leave Q&A to the end, but we've got Ollie and people here to answer your questions. So yeah, so let's get started. Right, so firstly, what is Niagara? Hopefully you all know that's why you're here, but it's the new particle system in Unreal. So been promised for a long time, been in development for a long time, but as of 4.25, it's been released out into the wild with their sort of 1.0 release of it. So if you're on 4.25, then you should have this effects tab here full of Niagara options and things we're going to create. If not, if we go to the plugins, so if you're on 424 or 423, I think, you should have Niagara here, and you can turn on and see here it is version 1.0, and it doesn't have the beta flag anymore. It's obviously still in development. It's a little bit buggy in places. Hopefully we won't have any crashes, but they are obviously still working on the stability and the features and everything, but it's pretty good now. It's ready to get out there and start being used. And it's my understanding that with Unreal 5 coming next year, that Niagara is going to be the only option. So as of now, you can use Niagara and Cascade together, but from next year when we get the new engine, that's going to be a thing of the past, and it's just going to be Niagara all the way, which sounds pretty cool. So if we just right click in our content browser and create a new asset, you see we have particle system, and this is Cascade. This is the old version, and I'll just create a quick one to have a look. If you've done any particle work in Unreal, you'll have definitely used Cascade, but yeah, now it's all being kind of like being replaced with Niagara slowly. So key differences. So for a start, the UI is horrible and old, and we don't really want to use Cascade at all. And it is a single actor that contains within it different emitters. So here we have an emitter. We can have as many of these we like inside of this system, and then the system itself is something we can drag into the world. And there we are. We've got our particle. Now Niagara does very similar things, but it has one really key difference, which I'm going to start with here, and that is separating out the system and the emitter into two different things. So this is a system. It lives in the world. Inside the system are multiple emitters, and here I've just got three ones called particle emitter, but these now are individual assets that you can then edit and inherit from, and it allows you much better content sort of data management. If you've done any material work, you might be familiar with the material instance system. So any material network you've made, you can create an instance of. If I just open one up here, and you can override parameters on a per instance basis. And that's kind of the same workflow now with particles. So we'll see a bit of that, hopefully, with our systems today. So what we're going to be doing, well, I'm just going to start by creating a Niagara emitter. Now, if we click this, we get this sort of little template-y window, little wizard, and we're going to create a new emitter from a template. So Niagara comes with some pre-made templates for us, and what we're going to be doing is creating this hanging particulates, so little dust motes in a volume. And we're just going to create one of these, and then later on we're going to go through and we're going to start with an empty template and just create all of those bits for us. See how they're all made. So give it a name. I like to use any for Niagara emitter. There isn't really a naming convention industry-wide yet for Niagara because it's brand new, but any makes sense sort of with Unreal's existing naming conventions. And I'm just going to call this hanging. So notice this is an emitter. So if I try and bring this into the world, I can't do so. So this is what I say is a slight difference between how Cascade worked before. But if I open this up, we have our UI, nice and new, shiny, looks much nicer, feels much nicer, much easier to work with than Cascade. So we'll break this down. So we have over here our viewport. This is a looping particle system, so it's just going to spawn in the world and then carry on looping. We have a look at our timeline down here. We can see time is moving forwards. And in this preview, every 10 seconds, it's going to repeat and go back to the beginning. But if we place this in the world, that wouldn't happen and it would just keep on looping. So one thing to note, yeah, there's a slight difference between this viewport and what you're seeing here and what you'd actually see in the game. A few options up here for the viewport. We can see a particle count. It's quite useful to see what's going on, how many things. Basic 3D movement, same as the other, or the rest of Unreal, so you can zoom in and out, fly around. And we have this background. So this is Epic's offices in Renton, I believe. But we might want to edit that, make it look more like the game we're making, or remove it and have it kind of black, a bit more like Cascade used to be, make it a bit clearer. So up here in Window, we've got preview scene settings, and this is controlling this background. So you can just go in here, put things in the desert, control different cube maps, nice sunset, or for just turn it off entirely. So for the sake of clarity here, we're making little glowing dots. I'm just going to have them on a black background, make it a bit easier to see. So yeah, preview scene settings, we can adjust our viewport. It's a much nicer viewport than Cascade has. Still not great. You always want to kind of see things in world, but it's not a bad preview, better than it was. Moving across, we have our parameters tab. So we'll get on to what these do later, but there's lots of data we have in the system that we can then use to drive other bits of data, really powerful workflow, and we'll cover that later. And then we have the actual emitter itself here in the sort of system overview. So this has obviously been named hanging particles, and each one of these modules is controlling a different part of the Niagara simulation. So here, initialize particle. If we look across to the size here, we have one saying sprite size and a minimum and a maximum value. So don't know how easily you can see those on the stream, but if I up the size, we're going to get much larger particles. So this is how we're going to work to do basically everything, setting up a module and then controlling the data and the values within that module to control part of our simulation. This example comes with quite a few modules, and we'll go through what the different ones are when we make our own version of this and add things to it. But there are a lot more. So we click the little plus icon at the end of each of these sections. We get a whole load of different modules that we can have. And one of the powerful things about Niagara, not that we're going to have time to go into it today, but if you double click any one of these modules, you can actually go inside and edit the code using a node-based editor. So a bit like blueprints. And again, that's well beyond the scope of what we're doing today, but a really powerful way of working with Niagara versus Cascade. You don't need a programmer to write your modules for you. You can just make your own using the visual scripting. So cool, right. So these different sections, what do they do? Well, there's a very clear difference between the different parts now that kind of existed in Cascade, but it was a little bit more implicit and kind of woolly. You didn't quite know where things should go and whether it was affecting things once or over a lifetime. And so now we have these four clear sections: emitter spawn, emitter update, particle spawn, and particle update. So the two spawn sections, they happen once, just on spawn, and that's it. So emitter spawn happens when this emitter is created. If you think about it, if it was like a spark effect and it happened when you fired a gun, hit the wall, that would spawn once and all that data, all that logic would run once. And then emitter update would be over the lifetime of the particle, of the emitter living there. So in this case, we've got something like a spawn rate. This is controlling how many particles exist within our system, our simulation, and this needs to happen every frame. So every frame of our emitter living, it's spawning new particles, and we can see if we have these numbers, we're going to get a lot more or a lot less. Similarly with the particle spawn, so the initial size of our particle is being driven by the particle spawn, so the initial particle size happening all here, it happens once over the whole lifetime. And then things like scaling the size, scaling up and down, that's happening here in the particle update. And so when we build our own in a second, you'll see modules have different positions they need to be in, whether we're doing something just once as a sort of setup, or whether it's kind of an animation as something is living. Cool. Right, well, let's have a go at building our own then, and we'll go through the different modules as we add them on and build up our own version of these hanging particles. So I'm going to create a new emitter. From a template, I'm going to use the empty template here. So it's going to come with a few different things. So it comes with a few settings or a few modules already in there, but actually we're not getting any particles, not getting anything here. So it's a very kind of blank slate for us to start. And I might just open the other one. So I've got a comparison. So I can jump back and forth and see what's there and what's missing. So first thing I would like to do is add some particles. So we're adding particles over the lifetime of the emitter. We want to spawn a number of particles every second. And so if we click on the little arrow or little plus here next to emitter update and type in spawn, we can see we've got different ways of doing spawning. And what we're going to have here is a spawn rate. And it's just going to be a number of particles per second. So if I do 20 or 50, we're now spawning a number of particles, and we can see that up here in our particle count. Now, it's not very interesting. They're all completely on top of each other. So we need to give it some kind of location to actually spawn those particles within. And again, this is happening at the emitter update, I believe. Box, nope, got it wrong. Sorry, it's happening at the particle spawn, because each particle, when it's spawned, you need to know what size or where in the box does it need to be spawned. So as I say, Niagara is quite new. I'm still getting my head around the locations things need to be in. Wasn't an issue with Cascade, but if it's not in the one you think it is, then just try the other and it'll be in one of them. So now we have added a box location, and we can see we've kind of defined a cube. It works slightly different to Cascades. It used to be just a min and a max value. Now we have a center and a size. And so here, if I change that to 200 in X, we're going to get a longer, thinner box. And we can see we're sort of spawning those particles within that. Now, I said we'd talk about parameters. If we have a look here, we've got this particle parameter being used here. So the box origin is set to be the particle's position. And if I just make a system out of this emitter, so I can bring it into the world. Remember, emitters don't live in the world. Emitters live in systems. So if we right click, we can create a system based off this, and it's just giving it same name there. If I just bring in a copy of this, we're getting our kind of little particles. What I want to do is change that initial size, even my particles, that initial location. So rather than being at the particle's position, I'm just going to overwrite that to be a local value. And here it's going to be 0, 0, 0. So no change in this viewport here. Nothing's changed that, because where the emitter is in this viewport is actually the same as 0, 0, 0. Whereas if I go to the world now and have a look, if I just compile this, compile and apply this. Oh, I've created a system from the wrong thing. Apologies, I need a system of my particles. There we go. Get rid of that one. So my particle system here lives in the world over here at this position, but the particles are being spawned with the box at around 0, 0, 0. So this is the world origin. So we don't really want to do this. We want to keep that box origins. We want to use the data that already exists within the emitter to drive that. So if we put that back to particles position, again, no change here in terms of the visibility and change of where the particles are spawning here, but now it's being driven by the particle emitter's location in the world. So we're using some data from the emitter to drive the location of those particles. which is pretty cool. So currently just spawning particles in, just being dropped into the world. We're getting what's called popping, or what I would refer to as popping. Each of our particles is spawning, and then it's a big change happening in one frame. So there's no soft fade in, there's no kind of like opacity fade in, there's no kind of like finesse to these particles. They're just appearing and then disappearing. And so what we need is some way to control that over the lifetime of the particles. So we'll do that in the particle update. So let's do color. And what we're going to do is going to scale the color of the particles in and out. Now we've added a color module here, and we've got color information here. If I change this to be red, I can overwrite the data that was already in the initialized color. And this is now being updated every frame, but we want this to be an animation. I don't just want a single value. And so what I can do is use a curve. So here we've got a color from curve. So this little down arrow at the end of any data allows us to change what the input to that data is. So in this case, this is just a constant value, white and an alpha 1. And if I change that to be a curve, I can now do a color from curve. So if we have a look, might be a bit difficult to notice, but you see the particles are fading out, because that's the alpha now goes from white to black, and black in the alpha channel is going to fade the particles away. So if I just bring in here, I can add a new keyframe, shift click, we'll add another keyframe. If I set that opacity to 0, you can see we're going to fade in and then fade out. So anytime we want to do an animation, we want to adjust the values over time, we need to do a curve. And there's this little button here. This curve editor is quite good. We can see, I can adjust the color, things like that. Maybe I'll make them go different colors as well. Start in blue and then red. And you can see how just editing those keyframes, and now I'm going to get these sort of weird glowing circles. If we do want to see a bit more information, or this in a bit of a larger kind of UI, you've got this option here, and we can add it to the curves tab. This is just a separate window, and you can sort of access the individual channels, red, green, and blue, turn them on and off, this kind of thing. And if you notice the keyframe we added, which was actually this one here, we can adjust the tangents. So here, if I just show the alpha, it's linearly moving up, and then there's a nice smooth curve on the animation coming out of that keyframe. And if I just go in here, I can set that to auto, and now we're getting a nice smooth curve. And we can obviously adjust these tangents. It's pretty sort of fully featured graph editor. You can make them kind of pop in, come in and out. It's pretty cool. So one of the other features that existed in the original, as well as color, we could also scale things in and out. So if I go to my particle update, and I'm just going to type in size. So we're using a sprite here, we're not using a mesh. Again, beyond the scope of what we're doing here this evening. But if I scale my sprite size, if I have a look, I can scale my particle. I can make them long and thin. I can make them tall and wide. But in this case, I don't want to scale the two axes independently. This is what's called a vector 2. It has two components, one for the X scale, one for the Y scale, and you can see how we can get long and thin particles that way. But I don't want to create an animation where I'm animating both parameters. I only ever want to have uniform scaling. So what I can do, if I type in float, you can see here there's vector 2D from float. And so a floating value is just a single value, and then it's going to convert into a vector 2D. And the way it does that is just by taking the same value in both values, if that makes sense. So now if I plug in 5, it's going to convert that to 5, 5, and we've got uniform scaling. So one of the really nice things about Niagara compared to Cascade is this ability to build up our own little input math and sort of control that quite powerfully. Quite a lot of control we've got here, quite a lot of detail we can add without having to sort of go into the module level, just by changing the inputs and doing a few sort of layers of maths within that. So now that I'm doing a vector 2D from a float, I want to animate, so I can do a float from a curve. Excuse me. If you remember, anytime we want to do some animation, animate over a lifetime, we're going to use a curve. So default values starting at 1, scaling down to 0. And if we zoom in a bit, you can see as these particles are getting redder, they're also getting smaller. So we've got this sort of connection between those two values. Now, I probably want to scale in and then scale out. So shift click just to add a new keyframe. And then I like nice round values. So I'm just going to type in some values in here. 0.5, 1. And again, if I click to show on curves, it's actually going to add it to the existing curve. So you can edit multiple curves at once, which is quite a nice sort of system to be able to see multiple curves and how they kind of interact with each other. So, but for now, I'm just going to just isolate that one, and I'm just going to adjust the tangents again so that they smoothly fade in and fade out. And we're getting particles zooming in, particles fading in, colors adjusting. Now, one thing to notice, the curve index, so how we're reading this curve, well, it's using what's called the normalized age. If you think about it, if we go to our initialized particle, these particles are living 5 seconds. Well, it's not very random. We're trying to create something maybe a bit more natural. We don't necessarily want to just use a single value for our lifetime. We want each particle to have its own lifetime, but we want our scaling, our size, to always be reflected in the lifetime of that particle. So here, if I set my lifetime back to 1, now my particles live a very short amount of time. But the scaling in and the scaling out, it always happens at the start and at the end of the lifetime. And that's because it's using what's called this normalized age. And so no matter how long your particle lifetime is, 1 is always the end of the lifetime. What we might want to do, create a bit more random variation. Rather than just having a single value where every particle has the same lifetime, we might want to use a random value, might want to use a range. So again, little drop down arrow at the end, going to create an input. Now, I know from Cascade that this is called a uniform distribution. But if you just think about, you want something to be random, if you type in random, it actually gives you a uniform distribution there. So the search bar that you're doing here, it knows that this is what you're looking for. And we're going to do a uniform range float. What does that mean? Well, it's just a min and a max value. So if I say at least 1 second up to 5 seconds, now some particles are going to spawn in and live a very short amount of time. Some of them are going to live a lot longer. But because of that normalized age, it doesn't matter how long they last. They're always going to kind of fade in and fade out based on this curve that we've got here. Pretty cool. A few more random things we might want to add. Currently, all our particles are the exact same size. So we're scaling that size. This is a multiplier. And so 0 and 1, these are multiple values or multiplier values. But we've got here in our initialized particle, different values for the particle sprite size. So again, this is a vector 2D. If I set this to be, it was already 5, set this to be 50, we're going to get long and thin. We can adjust these separately. But again, I just want uniform scaling. I always want them to be the same. So we'll just do the same trick. So rather than doing a vector 2D, we're going to use a float value and convert to vector 2D. And then here, we're going to create a random value in our sprite size. So a uniform range float. And we can have some particles which are big, some particles which are small, and we can combine that together. Not look too much like the source. We've got a bit more life and color going on with ours, but it's all the same technique, just slightly different data. There's a couple of things that we're not not implemented yet. We don't have any movement. So if we go here, there's a couple of things happening. One is this thing curl noise. So with Cascade, you had to use linear movement, or you could load in vector fields and things like that. But actually one of the things they've added in Cascade, in Niagara, that's really nice is this thing called curl noise. And it's just a sort of random moving noise thing. So just kind of like creating that kind of that feeling of dust floating. It's not moving around in a linear direction. It's not just falling or not just moving sideways. It's got a little bit of what they call curl noise to it, so it's moving around. And we get this error when we add curl noise. So what's happening here? Well, if we read through this, what's happening is we need our solve forces and velocity. This is a module that just comes with our template. It needs to be the last thing. So if we're telling it to move, the last thing we need to do is solve it. So if we did have gravity and curl noise and all those things combined, we need to have solve forces and velocity as the last thing. So if we move that down manually, that'll fix that error. But actually, if I just put that back above, there's a really nice button here. It just says fix issue, and it'll do it automatically. So if you're ever seeing that error, obviously read it through, but they've handily added this fix button, which just automatically fixes our sort of system for us, puts the modules in the right place. So it's a little difficult to see because the particles don't live that long, so I might just increase the lifetime a little bit. But if you follow an individual particle, they're not moving in a straight line. They're kind of moving and then sort of along a certain direction, and then they bend round, and we get this kind of quite nice natural feeling to this. And we can adjust how strong that noise is. That's going to be much more of a force to this now, and the sort of the size of the noise, or the frequency of the noise. And we can get some quite nice motion to our particles, which is pretty cool. One other thing that they have in their example is a drag. So we create a drag field. This is also going to be in the wrong place, but we can just click fix, and that's just going to slow our particles down over time. If I give it a little bit more drag, they're going to spawn, move around, and then rather than animating them, rather than sort of like giving them a velocity curve and scaling their velocity, we're just going to slow them down a little bit with drag, and we get these sort of slightly more interesting motion, which is pretty cool. So again, it doesn't quite look the same, but it's the same kind of principles. I think mine looks much more interesting, much more exciting. And so one more thing I want to sort of go over with this sort of example again is how we then bring that into the world. So we did do it briefly earlier, just to show off that particles being at world 0. So I'm just going to go over it and do that again. If I just delete these, let's just save first, just in case anything crashes. Send me it's in use. Well, so if I've got my emitter here, NE, my particles, we want to create a system from this emitter. So if I just right click, create Niagara system, I'm going to rename this NS, I don't know, my system. So the way the system works, one thing I missed earlier, if we look down here in the bottom of our overview, this one says system, and this one says emitter, so you can sort of know which of the two contexts you're working in. It'd be nice if there was maybe a bit more variation between them, just because they're quite different things and look very, very similar. But yeah, there's a word down here, and the system also has the system settings, which we'll get to in a second. But you can see here in my system, I've got the particles emitter that I've brought in, and what's really nice is now this is in the system, I can override those values. So if I go in here to initialize particle, let's say I want to say, oh, they're too small, let's make them much bigger. If we have a look, that's going to be reflected here in this system, but not in the parent. Ooh, that's the wrong thing, that's the parent. And so you can create a kind of a core emitter or particle. So let's say you're making like a campfire, you might have a flames emitter that you've built, and then when you bring it into the system, you can scale those up or change the color slightly and sort of keep that inheritance, keep that system, so that you've still got that that link back to the original emitter, which is a really nice way of working. On that, with the UI, you've got two little icons here at the end. You might be familiar with the reset to default value, and there's a new one. So the second arrow, reset to parent. So here I've overwritten the size, and we can see the size being different here. It's larger in this system. And if I just click that, it's going to reset back to the parent. New sort of UI, really helpful if you kind of just want to test something out and then go back and adjust, reset that back to how the parent is. And we can add new modules. We don't have to just keep the modules the same. So let's say we've made these bigger, cool, but we want some whole new motion. Let's say we want to add some gravity. Well, there's a gravity module. Again, it's a movement or forces module, so it needs to be in the right place. If I just set that down to something much smaller, we can have a whole new set of data, of context here. So if we add this gravity to this emitter in this system, but it's still keeping the original data from here. So just to show that off, if I say, I don't like these colors, let's go green to red instead, that's going to be adjusted here in the emitter level, and it will in the system. But before we can do that, we have to compile and apply. So when you're working in your emitters, if you want to see those changes in your systems, you need to make sure that you compile the same way that with a material, you'd have to build your material or compile your material. We jump across now, because those colors weren't overwritten, that inheritance stayed there. So we can choose which bits to inherit, which bits to override. Really powerful, quite complex system compared to how things were with Cascade. Cool. So one last thing I think for today. If I bring this particle system in, we're spawning our particles. Again, it's the system that's coming to the world. If we want, we don't have to have just one emitter per system. This is something that was crashing my engine for a while, so maybe I'll just save. Maybe I'll keep that for a second, but we can add in multiple emitters. So for example, we can have one system with lots of different sub-emitters. I've got an example, that's probably a better way to do it. So if I open this system here, we can see we've got lots of different emitters there, and each one working with that inheritance from the emitter, and then you can repeat them multiple times and all that kind of powerful stuff. But the one thing I did want to show with this, if I just bring this back, if I reset my emitter, you can see it takes a couple of seconds to spawn in. And that's the setting that we have to edit at the system level. So if I click on system properties, we have this thing down here called a warm up. If I make this bigger. Now this can be a little bit expensive, but if you want your particles to be on screen the seconds that you spawn, you may have noticed in games, you kind of like load into the game and then every set, so for the first second, there's no particles around, and then suddenly all the fires can spring to life. That's because they're not using a warm up. If you want to pre-calculate that beforehand, you can do, but it comes at a cost. So let's say if we just spawn 2 seconds or calculate 2 seconds worth of particle before it spawns, and you can see now we're getting particles visible every time we reset. It's a little bit low. Get that to 3, and then we've kind of filled that volume. But yeah, they just come with a performance warning. I don't know if it still does. It used to in Cascade. Maybe it's better there now, but yeah, nice to be able to have an example of a property that's edited at the system level rather than the emitter level. But yeah, can be a little bit expensive depending on how expensive your particle system is. So cool. Okay, I might just, no, yeah, let's leave it there. That seems like a good amount of content for this evening. Obviously, we've ended up somewhere quite different from the original sort of hanging dust, but hopefully you can see that it's all the same modules. We're just using them in a sort of slightly different way. And then the kind of Niagara emitter system kind of hierarchy, which is, like I say, quite different from how it used to be in Cascade.
Cool, man.
Cool.
Oh, nice. That was really good.
Awesome. I have had a question. Can you limit the velocity of a size You limit, let's say, the velocity to the size of the particle. So there is a module, I do size. You can do size by velocity, I believe. Scale. Scale sprite size by speed. There we are. Apply that and see how that works with these. Not used this module myself, but it definitely does exist. There we are. We're having an effect. There we go. I just make the gravity a random value. Getting some kind of result. Maybe the drag's not helping. That's kind of what you want to do. So the particles which aren't moving very fast and are staying around the center are much smaller. The ones that are moving away are a bit bigger. But yeah, there's definitely ways of combining the speed of the particle in the size. So you can have really long, thin, fast ones and smaller, slower ones. That's kind of the beauty of Niagara is anything you want to do, you can. You just have to know how to sort of combine the two things together. So sometimes it'll be a module here where you can get the one of the ones that's sort of preloaded with the engine, or maybe you'd have to create your own module. We didn't really have time to go over them, but in here we've got different ways of creating your own kind of modules, which can then be loaded in. So you could very easily create something that was combining velocity and color and that kind of thing. So you could build some very cool dynamic sparks that would all build their colors and lights and things based off velocity. So yeah, totally possible. It's all possible if you know how. Before I go, I do just want to say a bit of self-promotion. So I have a YouTube channel, and on there I've done some more introduction to Niagara videos. So we've basically covered what was covered in the first video there today, but I break down some of the other different renderers and things, all sorts. So go and check that out if you want to know more Niagara stuff. And also Chris Murphy, who's someone who works at Epic. He's one of their evangelists. He's done a lot of the Niagara video tutorials as well. So building advanced effects with Niagara. And then, yeah, check out some of his stuff as well. Cool.